Let's start this section off with some review. The first derivative being bigger than 0. First derivative world, what does that mean about what's happening to the function itself? So if the first derivative is positive, we're picking between increasing and decreasing. First derivative being positive means the original function's increasing. Can look so many different ways. It could be rising sharply. It could be more of a linear function like that. So many ways to draw increasing. First derivative being negative means the original function is decreasing. Remember, first derivative world, you're picking between increasing and decreasing, and negative means it's falling left to right. It's decreasing. We read graphs just like we read English, left to right, and as we follow it, it's going down. Second derivative world, we are picking between concavities. So if the second derivative is bigger than 0, that means positive. The original function must be concave up. So concave up gives us a really good idea of what the graph looks like. So concave up could be a full U, it could be just the left side of the U, or it could be just the right side of the U. Really only a few ways that it can look. And if we trace these left to right, we can figure out what the first derivative is doing. So at first, this one starts and it's falling left to right. So this has a negative first derivative. This off peak has a 0 first derivative. That's where the critical number would be. And then if we trace it again, it's rising left to right, so we have a positive first derivative. If we just have the left half of the U, this graph is going down as we follow it left to right. So it has a negative first derivative always. And this last one, if we follow it left to right, is going up. So it has a positive first derivative always. So as long as we know concavity and increasing, we have a really good idea of what the graph looks like. Or concavity and decreasing, those two combinations really narrow down what the graph could look like. If the second derivative is negative, that means the graph is concave down. So we can draw our 3 U's. Maybe I'll draw them down here to not overlap. We can have a full upside down U, just the left side or just the right side. So when we think about the first derivative of these, this one's rising at first. So it has a positive first derivative. Then the derivative must be 0 at the soft peak. And then it's falling left to right. So it has a negative first derivative. This one's concave down, and it's always increasing. If we follow it left to right, it's going up. This one's concave down. If we follow it left to right, it's always decreasing. So then we can use this to sketch some pictures. We want to know that when we sketch these pictures, mostly we are concerned about this concavity. That really narrows down what the picture is going to look like. So we're going to think about that first, and then also consider the first derivative as well. So looking at this first graph, it says draw a continuous function on negative infinity to infinity. So that means we want to be able to graph it without picking up our pencil. So don't pick up your pencil. You might have to while you're graphing it, but then when you go back and trace the graph, you should see there's no discontinuity. You could trace it without picking up your pen, even if you have to pick it up while you're drawing just to make it look nice. So here we're given that the first derivative is less than 0. That means the function, original function, must be decreasing on negative infinity to 2 and 5 to infinity. And then we have the first derivative is bigger than 0, so we have something that's increasing on the interval from 2 to 5. So we want to remember that we can only switch increasing and decreasing at critical numbers. So looking at these numbers here, from negative infinity to 2 and then 5 to infinity, that tells me 2 and 5 are critical numbers. And then it also confirms it. 2 and 5 are the numbers here. So there's our critical numbers. And sometimes making a sign chart helps narrow down what the picture looks like before putting on the graph. So I'm going to make a sign chart for this one. You don't have to, but I do think it's helpful, at least for me. So we have 2 and 5 as critical numbers, and the function is decreasing on negative infinity to 2. So here's negative, it's decreasing, just to sketch off to the side, and 5 to infinity. So here it's decreasing, it's falling left to right. And then it is increasing on the interval from 2 to 5. Decreasing, and then interval from 2 to 5, it's increasing. So here we kind of connect them. So we're decreasing, increasing, decreasing. There's the general shape of what the graph could look like. Here we're not given any specific points that we have to go through, so I can literally draw that anywhere I want to. I'm going to tell you the points that I'm using just so it's easier for you to copy down in your notes, but it could be anywhere. So at 2, I'm going to say that the point is 2, 1. And I'm going to be decreasing before there, and then I'm going to do the other point as 5, maybe 3. And then I'm just going to connect these. So I want to make sure I'm decreasing before, I'm increasing between the two, and then I'm decreasing after. So there's lots of answers. I just randomly chose some points to go through just so it was easier to copy down my graph, but it could have all been in like the negative y values, and that'd be fine. All the stipulation says is we have to be decreasing to start, increasing between 2 and 5, and decreasing after, and we definitely met all of those needs, as well as drawing something continuous. I did pick up my pencil to draw it just because it made it easier for me, but once I trace it, I can see that you can trace the graph without picking up your pencil, so you know it is continuous.